Okay, hello everyone. So today our lesson we are learning about electric fields. Okay, so what is electric field? And here you can find in this figure we have talked already, right? Oh, sorry, talked already that girl's head and her head are just moving like this direction, right? And we can find all her head here are just putting in a direct lines. Okay, so why is like this? So we have said before that if the ball takes negative charge, right, and maybe her head will also have negative charge. So here is also negative charge, right? So based the principles we said before that the same charge will have a repulsive force and the negative charge, a different charge will have a attractive force. So here, her hairs just attract with each other, right? Sorry, repulse with each other, right? So each hair just perpendicular to his head and just like this way, okay, like this way, and this way, okay. So they're just moving like this way, okay. This is for the electrostatic charge, okay. And next, we have this distribution of electric field. Okay, here you can find your on the left figure is a positive charge, and it just like shooting the positive fields outside. Okay, so here we have a very simple principle for this. That is the sorry, and here's some Chinese on it because I just finished a Chinese lesson with my students. Okay, sorry. Okay. And here, first is just from positive charge, and we find that it's just release electric fields. Okay, so maybe here you have a very confused about the electric fields. Why is it? So just a distribution of electric field, or you can just like a gravitational field strength, just a downward direction, and it's just a same value. Okay, so for here we can find when we are closing to the chart, the wires or the lines are just very close to each other. Okay, like this way. So we can set right here. It's just like built in this way. Okay, so just releasing the positive lines outside. Okay, so we can regard it here. Here are two principles for this. First is that it is released outside for positive charge, right? This is for this charge. And secondly, we can say right here, out of this principle is that when we're closing to the positive charge, that the electric field is very strong, right? Because it's a very close to each other's lines, right? So close to positive charge means that close to positive charge means that lines are very close to each other, right? And that means right here, it has a very strong electric field. Okay, so here are two principles for this. And you'll find in the right figure, there's a electric charge. And there are many arrows just shooting from the outside, right, towards the negative charge. So we can say right here, for the negative charge, it has this kind of distribution. So the arrow is just shooting to the negative charge, okay? So they're very similar to the figure we had talked before, that a girl's hair is just perpendicular to her head, right? That's because there is a direction for the field, but we can feel it, but we cannot describe this, right? So now we can using these arrows to represent for the direction, right? So for the electric ball, you can find each rays are just moving like this way, this direction, like this way, right? Because it's perpendicular to the surface of her head, right? This is very interesting, okay? This is for the first property. You have to remember that this is a distribution for electric field, okay? And secondly, after this distribution, and then we are moving to another kind that is called like here, if we have two different charges on the screen, you can find there's a positive charge and a negative charge, right? And here we have already discussed before that positive charge release the electric field and negative charge gains electric field. So just one release, one gains, like this way and distribution, okay? So we can have another property. You can find each lines are perpendicular to the surface of the positive charge and negative charge, okay? So the third property is that every field lines doesn't have any intercept and they are perpendicular to its surface, okay? Okay, so this is a very important property for how to draw the electrical field. Okay, so here is for the third property. And for the fourth property, you can find there's another positive charge and positive charge. You can find here in this situation, they have released their electric field and they have no interception and they're perpendicular to the surface. So you can just draw like this way, okay? And Okay, you can find in the last figure, here's an example, like from the positive plane to a negative plane, and you can find there all lines are parallel, right? And they're all perpendicular to the surface of the positive plane and negative plane. Okay, so we can say here is how to draw this. Okay, and in IGCSE test, sometimes we have 2 points for drawing the or sketching the graph. So the first point is for you are drawing perpendicular lines. Okay, you are drawing perpendicular lines to the surface. Secondly, you have to draw from the positive part to negative part. So the arrow is from positive to negative. Okay, so this is our 2 points you have to draw it. Okay. So in the test, maybe we have these patterns like this way. You can find for the negative balls, there are charges inside of this, right? And all arrows are perpendicular to this. And we knew that the probability is that for positive charge to release, right? Release the electric field, and for negative charge is to like shooting or like gains electricity or just like the arrows just towards the part, right? And second probability is that it's perpendicular to the surface, right? And the third probability is that there's no intersection between the lines, right? So we can find on the first figure, there are negative charges on the surface of the ball. So each lines are perpendicular and shooting towards the surface, right? This way, right? And for the second figure, you can find there's a one positive charge and one negative charge. So from left to the right, the electric field just from the positive to negative, okay, like this way. Just shooting outside, like this way, okay? So this is for electric field. And on the third figure, you can find there's a positive charge plane to the negative charge plane, okay? From this way to this way, okay? Each direction just shows how it shifted, okay? This is for the electric field between the two parallel plates, okay? And maybe you have a question. So, Teacher Mai Lin, I'm wondering why the above arrow and like the bottom arrow, they're just shooting like this way. Okay, so why they're just like a curve, but not a very straight lines? Okay. So please remember here, there's a curve because there's at the corner or at the very turning for the place. Okay, so you can find this corner. So it's just like a curve. So perpendicular to the curve, so the lines must also be perpendicular. So must also be a curve, right? Like this way. Okay. So this is for the electric field. Okay. And another example is for curves and points. Okay, so for here you can find here's a very sharp object right here. You can find it's just like a packet, okay, pocket, right? Like this way. And you can find at here, at this corner or at these very sharp places, it's just like shooting outside for many arrows outside, right? So it's like just shooting outside this way, this way, this way. And because it's a negative charge, so each electric field just shooting like this way. And we have already talked already before that is when the electric field is very close to each other, right? So we think this is very close to the like the substance which is like emitting the electric field, right? So we can find on the very top of this, because their density of the lines is very big, that means the electric field is very big, okay? Okay, so this means electric field very big, and it has a very sharp or very big ability to form an electric field. Or you can say that because it's very sharp, so that can form a very big electric field. And for here, you can find maybe for very sharp places, you can find that their ability is also very big. Even they can just make the air to ionize into the positive charge and the negative electrons. So there is for the ability, okay? So you can find why the sounder wants to like make a click on the very tall buildings. That is because this is very sharp and very easy to form a very strong electric field line, so they can attract the sounder very easily. Okay, this is for the percent points. Okay, so here's an exercise for you to master for this today's lesson. Okay, so please choose an answer for the which the electric field is the biggest. Okay, try to solve for this problem, please. Okay, I guess you have your answer, right? We are choosing A, right? Because in the A, we said right here, because it has the biggest or strongest electric field, okay? So here is why we're choosing A, okay? because the rays are very dense with each other, so which means that it's a very strong magnetic field. Okay, no, sorry, electric field. Sorry, here's electric. Okay, so we are choosing A. Okay, so here is for our today's lesson. Hope you can understand all of this. And next part, we are talking about what is electrical circuits. Okay, see you next time. Bye.